In the previous class, we have seen some rules regarding the congruence of triangles. Specifically, we have seen the SAS rule. Let me write down here. We have seen SAS, side angle side rule, and we have two sides and one angle equal, and that angle has to be between the sides. It has to be included between the equal sides. And then we had the two angles and one side rule, where we had angle side angle, but the angle side angle rule does not require the side to be included between the equal angles, so we can have it as AAS or as well as SAA. Okay, all these are applicable rules which can be used to prove the congruence of two triangles. So let us today do a few examples using the ideas of the SAS and the ASA congruence of triangles rules. Okay, so in the first example here we are given a quadrilateral ACBD, and we are given that the side AC is equal to AD. So AC is this side and AD is this side. These are equal, and we are also given that the line AB bisects angle A. So that means the total angle A is divided into two equal halves. So that angle is equal to this angle. So they are equal. So AB bisects angle A. Now we are asked to show that the triangles ABC, which is ABC, the triangle on the upper part, that is the upper triangle, and the lower triangle, which is triangle ABD, these two are congruent. And we are also asked about BC and BD, that is these line segments BC and BD. What can you say about them? Okay, let us look at those two triangles ABC and ABD and see whether they are congruent or not. So let's write in triangle ABC and triangle ABD. Let's look at what are the sides that are equal. First of all, we are given that AC is equal to AD, so that means one side is equal. So in triangle ABC we have AC, and that is equal to, in triangle ABD we have the side AD. So AC is equal to AD, that's given to us. So that's one side here. Then we have the angle CAB equal to angle DAB, because the line AB bisects angle A. So we are given that angle CAB equals angle DAB. So that is our second condition which is given to us. And the third condition which we can extract from this diagram is that in both the triangles the line AB is a common line. So AB belongs to the triangle ABC as well as it belongs to the triangle ABD. So that's a common line. So in both the triangles, because it's a common line, it has to be equal. So AB equals AB. So we have a side which is equal, we have an angle which is equal, and we have a side which is equal. So this will give us the SAS congruence rule. So by SAS, by side angle side, we can say that the two triangles, that is triangle ABC, is congruent to triangle ABD. Once we have shown that the triangles are congruent, we can now show that the other sides or angles of the triangles are equal by using the CPCT property, the corresponding parts of congruent triangles. So by CPCT, we can say that the side BC is equal to the side BD, because they are the corresponding parts of the two congruent triangles. So by CPCT, BC is equal to BD. So that's the second part of our question, which asks, what can you say about BC and BD? BC and BD are equal because they are corresponding parts of the congruent triangles. So by applying CPCT, we can say that they are equal. So that means BC is equal to BD. Okay, so we have marked this. So we have these two triangles. So AC is equal to AD, BC is equal to BD, and AB is the common side for both the triangles. So that is equal anyway. So once we have proven the congruence by any one of these properties, we can then apply CPCT to show the equivalence of the other sides or other angles. Let us now look at another example to understand this even better. So again here we are given a quadrilateral ABCD. So we have ABCD as a quadrilateral, and we are given that the side AD is equal to BC. So AD over here, I marked it with a single black dash. So AD and BC are equal, and we are given that the angle DAB equals the angle CBA. So these angles which I have marked here are equal. So we are now asked to prove that triangles ABD, this triangle over here, ABD, and the triangle BAC, this triangle over here, these two are congruent. And once we prove that they are congruent, we are then asked to prove whether that BD is equal to BC. What is BD? This is the BD, and this is make a correction here. BD equal, you have to show that BD equals AC, not BC. Okay, make a correction. I'm going to erase that. We are supposed to show BD is equal to AC. So that means we have to show that this BD is equal to this line BC. And then we also have to show that angle ABD is equal to angle BAC. ABD means this angle here, from here to here, is equal to angle BAC, means BAC, this angle over here. Okay, so let's first proceed with showing that the two triangles are congruent. Once we prove that they are congruent, it will be easy to show that the two triangles have the other parts also equal, because we can apply the CPCT rule once we have proved congruence. So let's write the two triangles. In triangle ABD and triangle BAC. Let's start writing the parts that are equal by the information that we have. Okay, the first information is that we have AD is equal to BC, that is given to us. So AD equals BC. Then we have the fact that this angle DAB is equal to angle CBA. So that angle and that angle are equal in both the triangles. Angle DAB equals angle CBA. Okay, and then to show the congruence, we have to look at both these triangles and see if there is any common side. So if you look at the triangle ABD and triangle ABC, clearly AB is a common side for both the triangles, so you can use that common side. AB equals AB. So now we can say we have a side, an angle, and a side, a common side, which is AB equal to AB. So again, we are getting the side angle side rule. Okay, so we can write by side angle side rule by SAS. Triangle ABD is congruent to triangle BAC. So these two are congruent triangles, and once we have shown the congruent triangles, we can then proceed to say about the second question, which is we have to prove that BD is equal to AC. So we have to prove this BD is equal to AC. Now if you look at the two triangles, they are the corresponding parts of the two triangles. So the corresponding parts of the congruent triangles will be equal. So by CPCT, we can say that BD equals AC. That's also proven. And the third part of the question, again, we have to show that ABD equals BAC. That means we are asked to show this angle. ABD is this angle and BAC is this angle. We are asked to show that these are equal. Again, these are the corresponding angles of the two triangles. So by CPCT again we can say that these two angles are equal as well. So by CPCT angle ABD equals angle BAC. So once we prove that the two triangles are congruent, we can then proceed to prove the other sides and angles are equal by applying the CPCT rule, which is the corresponding parts of congruent triangles. Let us now do one more example to show the congruence and to prove some properties of the sides of the triangle. So here we are given this particular diagram here, and it is shown that it is given that this line AD and BC are perpendicular to the line AB. So we have a line segment AB, and there are two lines drawn, which is BC and AD, which have the same length and are perpendicular to the line segment AB. So AD and BC are of the same length, so we have marked it with a black dash here, so that shows that they are equal length. And because we are given that they are perpendicular to the line segment AB, so we have the angle here, which is AB. The angle of BC and AD with AB is 90 degrees. And then what we can do is to compare the two triangles. So let's write in triangle OBC and OAD, OBC and triangle OAD. Okay, what can we say? First of all, we are given that BC is equal to AD, and we can look at this part here. These are two intersecting lines and the vertically opposite angles must be equal. So we can say that this angle, let me do that in a different color. So this angle here is equal to this angle here because they are vertically opposite angles. So we'll say that first we are given BC is equal to AD. Okay, then we know that angle CBO is equal to angle DAO. They are both 90 degrees. And then we have a third angle which is equal. These are given, both these conditions are given. Okay, this is given, both these. The third information that we can extract from the diagram is angle BOC. Angle BOC is equal to angle AOD. Why? Because they are vertically opposite angles. Vertically opposite angles. So now we see that we have a side and an angle and an angle. So we have the SAA rule. So we have to write it as SAA rule, or we could also write it in the opposite direction as AAS or SAA. So we have a side, angle, angle. side, angle, angle, or we can go in the opposite direction, angle, angle, side, or angle, angle, side. Either way, it doesn't matter, because when you have two angles and one side which are equal, the order does not matter. So you can write by SAA, by side angle angle rule, we can say that triangle OBC is congruent to triangle OAD. So once we know that these are congruent, we can prove that OB is equal to OA. So by CPCT, OB is equal to OA. So that means this line here, this side of the triangle OB and this side of the other triangle OA, they are equal because they are corresponding parts. So the corresponding parts of congruent triangles are equal, so OB is equal to OA. If OB is equal to OA, it means that this line segment CD is bisecting AB. So we therefore say, therefore CD bisects, let me write that clearly, bisects AB. Okay, so once you prove congruence, proving the other questions becomes much more simpler, because all you have to do is to apply the CPCT rule. Okay, but you have to be careful to apply the CPCT rule to make sure that you write the lines and angles correctly, which are corresponding parts.